Alright, what's going on, Algebra Bros? In this video, we are going to solve an inequality involving the average cost, average daily cost of manufacturing X bicycles. And they want us to figure out how many bicycles must be produced each day in order for the average cost to be no more than $130. So they give us a cost function here, 50x plus 4,000. Now if X bicycles are produced, then we can find the average cost simply by taking the cost function and dividing it by the total number of bikes made, which would be X if X bikes were made. So that's the reason for the second function, C bar of X, 50x plus 4,000 all over X. So that's a rational function, first of all, but it is based on just the simple a simple average idea. We want the average cost to be no more than $130. So that translates to this. We want C bar of X to be less than or equal to 130, right? No more than means that you have to be either less than or equal to. You just can't go above it. So we could solve this algebraically, but I'd like to show you how to solve it using the graphing calculator. So using the graphing calculator, we're going to enter two equations into the y equals menu. Y1 is going to be the average cost function, C bar of X, which that's provided to us. It's 50x plus 4,000 all over X. And then Y2 is going to be the dollar amount that we're comparing the average cost to, which is 130. Alright, so let's go to our graphing calculator. Y equals menu, going to clear out any equations I had in there. And for the numerator of this rational function, I suggest using parentheses. We want the calculator to know that 50x plus 4,000 is the entire numerator. Close off parentheses, and we're going to divide that by x. And then we're going to go down to y2, type in 130. Now, if you do zoom option 6, probably not going to see anything very helpful, if anything at all. And we definitely don't. So this is going to require us to do some window adjustments so that we can see these two graphs in action. So let's go to the window. Now the x min is set at -10. Keep in mind all the x values stand for the amount of bikes manufactured, so at a minimum x could be 0. But if you were to plug it into the average cost function, that would give it an undefined value. But regardless, we'll just make sure to exclude negative bikes being produced. Now as for the x max, if you notice in the answer choices, 50 shows up a lot. So I'm actually going to go a little bit beyond 50, maybe a lot beyond 50. I'll maybe go to 100, and then I'm going to increase the scaling of the x-axis maybe to 10, so that there's 10 tick marks on the x-axis. Now the y values represent the average cost. So what I'm going to do is put the minimum y value of 0, because hopefully we don't have an average cost that's negative. As for the y max value, we are trying to compare the average cost to 130, so I'm actually going to go a little bit higher than 130, maybe to 150, and then we'll do the y scaling at 10 as well. Alright, go ahead and hit graph. Okay, let's go ahead and sketch this out in our coordinate plane, keeping in mind some of the window adjustments. So x min and y min were 0. The x max was 100. The y max was 150. Now y1 is this curve. Okay, so I'll go ahead and include that in my diagram. So y1 did a little something like this. And then y2 was that horizontal line. Alright, that's as horizontal as I'm going to get with that one. Keep in mind that the green graph represents the average cost function, and then the blue graph represents the dollar amount of 130. Now, what might be helpful is to find this point of intersection, and you can probably bank on that being 50, 130, but let's go ahead and verify that on the graphing calculator. We're going to hit second trace, access the calculate menu. We're going to choose option 5. And we want to move the blinking cursor as close as possible to the point of intersection. Mine, serendipitously, is looking like it's already on the point of intersection, but if not, scooch it over to the point of intersection and press enter 3 times. And as I suspected, and probably you as well, the point of intersection is at 50, 130. So what I'm going to use from that ordered pair is the x value of 50. And I'm going to return to the original statement of this inequality. We want the average cost to be less than or equal to 130. So in terms of a graphical perspective, what we're really looking for here is any parts of the average cost function that happen to fall under the value of 130. And there's one piece of this average cost function that satisfies that criterion, and it would be this piece hooking down towards the right. That part of the average cost function is underneath the graph of y equals 130, and so that would be the relevant piece of the average cost function. Now, in terms of solutions, we want the x values that correspond to that piece, and those x values would go from 50 theoretically up to infinity, but obviously there are some real-life circumstances that wouldn't make that happen. And in terms of whether or not to include the 50, in this case you would want to, alright, by virtue of the bar being underneath the inequality symbol. And so in interval notation, this would look like 50, infinity. And so we would want to choose an answer choice that best lines up with something like this interval notation. So it says either 50 or more bicycles or 0 or fewer bicycles must be produced. Okay, so that doesn't seem to make much sense. If we had fewer than 0, that's negative. Option B says 50 or fewer must be produced. Between 0 and 50 must be produced. So option D says 50 or more bicycles must be produced. So I would say that option D appears to line up best with our interval notation, bracket 50, infinity. So that's how you'd solve this using the graphing calculator. If you're interested in the algebra solution, just let me know, and I'll be happy to take you through it. Otherwise, thanks for watching, and let me know if you have any questions. Adios.